Construction of a monolithic bipolar transistor. The fabrication of a monolithic transistor includes the following steps: epitaxial growth, oxidation, photolithography, isolation, diffusion, base diffusion, emitter diffusion, contact mask, aluminum metallization, passivation. So epitaxial growth, the first step in the transistor fabrication is creation of the collector region. We normally require a low resistive path for the collector current. This is due to the fact that the collector contact is normally taken at the top. Oxidation. As shown in the figure, thin layer of silicon dioxide is grown over the n-type of a layer by exposing the silicon wafer to an oxygen atmosphere at about 1000 degrees centigrade. This is photolithography processing. The prime use of photolithography in IC manufacturing is to selectively etch or remove the SiO2 layer as shown in the figure. The surface of an oxide is first covered with a thin uniform layer of a photosensitive emulsion. The mask, a black and white negative of a required pattern, is placed over the structure. When exposed to the ultraviolet light, the photoresist under the transparent region of the mask be cosmopolarized. The mask is then removed and the wafer is treated chemically that remove the unexposed portion of the photoresist film. The isolation diffusion. The integrated circuits contains many devices. Since a number of devices are to be fabricated on the same IC chip, it becomes necessary to provide good isolation between various components of their interconnection. The most important technique for an isolation are PN junction isolation, dielectric isolation. In PN junction isolation technique, the p-type impurities are selectively diffused into the n-type epitaxial layer so that it touches the p-type substrate at the bottom. These methods generated n-type isolation region surrounded by the p-type modes. If the p substrate is held at the most negatively potential, the diode will become reverse bias, thus providing isolation between these islands. The individual components are fabricated inside, and the most commonly used these methods are for general purposing integrated circuits. In dielectric isolation method, a layer of solid dielectrics such as silicon dioxide or ruby surrounds each component, and this dielectric provides isolation. The PN junction isolation diffusion method is shown in figure. The process takes place in a furnace using boron source. Base diffusion. Formation of a base is a critical step in the construction of a bipolar transistor. The base must be aligned so that during diffusion it does not come into the contact with either the isolation region or the buried layer. Frequently, the base diffusion step is also used in the parallel to fabricated diffused resistor for the circuits. Emitters diffusion. Emitters diffusion is the final step in the fabrication of the transistor. Opening must lie wholly within the base emitter. Masking not only opens the window for the emitter but also for the contact void, which provides a low resistivity ohmic contact path for the emitter terminal. The emitter diffusion is normally a heavy n-type diffusion, producing low resistive layer that can inject charge easily into the base. Contact mask. After the fabrication of the emitter, windows are etched into an n-type region where contacts are to be made for the collector and the emitter terminals. Heavily concentrated phosphorus N plus dopants is diffused into these regions simultaneously. The reasons for the use of heavily N plus diffusion is explained as the follows. Aluminum being a good conductor used for interconnections as a types of an impurities when used with silicon. Metallization. The IC chip is now complete with the active and the passive device, and the metal leads are formed by making connection with the terminals on the device. device. The thickness of the single layer metal is 1 micrometer. Metallization is carried out by the evaporating aluminum over the entire surface and selectively etching away aluminum to leave behind the desired interconnections and bonding as shown in the figure. Passivation, assembly and the packaging. Metallization is followed by the passivation in which an insulating protective layer is deposited over the whole device. This protects it against mechanical and chemical damage during a subsequent processing steps. Doped or undoped silicon oxide, silicon carbide, or some combinations of them are usually chosen for the passivations of the layers. The layer is deposited by the chemical vapor deposition techniques at the temperature low enough not to harm metallization. Thank you.